Hi everybody, welcome to another MyTutor online school tutorial. Today we're doing GCSE Maths and looking at sequences, so nth term and lovely stuff like that. So this session is 1 hour long and we'll finish at 3 p.m. Here's me, Molly, I'm leading the session. Just finished my second year at Bath doing computer science and maths, and I've done over 250 lessons with MyTutor now, which is super exciting. So throughout this lesson, do use the chat and Q&A functions a lot. It helps me to know where we're at, and if people are getting it, ask me any questions, tell me to speed up, slow down, whatever. Yeah, it's good to be really interactive. So as per usual, we're going to do a Kahoot at the beginning and at the end. And they're different, but exactly the same kind of level. I normally fail on that. The last one is normally a bit harder, but I guess we'll see. So we just see where people are at the beginning and see if we can improve by the end. And it shows me what I need to focus on. So yeah, go ahead and either go on the Kahoot app or kahoot.it. And yeah. So whilst people are joining, the topic that we're going over today, sequences. If you have no idea what nth term means or anything like that, don't worry. I always say this, it doesn't matter at all these first quizzes if you're guessing or not answering or have no idea. It's totally just to kind of engage you from the beginning and see where you're at. So all this is that the nth term of a sequence tells you if you want the 10th term, what kind of formula could you put in where you substitute in 10 and it gives it to you, and you substitute in 20 and it gives you the 20th term. For example, the sequence 1, 2, 3, 4, 5, etc., just the natural numbers, the nth term is just n, right? Because the 50th term is 50 and so on. So that's an idea of what it is. Maybe that will help you with the questions. I guess we'll see. I don't know what my hair is doing. Okay, better. So I'll wait. Not everyone is in just yet. I'll just give it 30 more seconds or so, wait for people to join if anybody else is. Yeah. It feels like it's been, well, I mean, it's been a week since I've done one of these. Crazy. Yeah, I assume most of you are back at school now, so I hope that's going okay. Well, if you are, I don't know what years are back at school, but anyway, I hope it's been bearable. Okay, I think I'll launch this, but the Kahoot pin stays at the bottom of the screen and I'll keep it unlocked so that you can join whilst we're going through. So let's do it. Question 1. So what are the first 5 terms in the sequence n squared? So remember what I said when you were joining about what the nth term means. I'm hoping that I've got all the timings right and like judged it correctly, so I shouldn't have to skip. It should be the right amount of time for each question. Okay, awesome. Yeah, loads of people getting that. So this is because it's 1 squared, 2 squared, 3 squared, 4 squared, and so on and so forth. It's just the nth term, the first term, the second term, and so on. So that's what that means. Second question, what about this sequence, 2n plus 2? So think about what I just said about that one and see if you can apply it to this one. Ooh, a tricky one, that one. Okay. I can totally see why people put this. You got the first term correct. Maybe you either jumped from there. So if we think about n equals 1, that gives us 4. So that's exactly right. If we think about n equals 2, though, we pop in 2. That's going to give us 2 times 2 plus 2, which will actually give us 6 as the second term. So interesting that the slip-ups there. As we'll learn, this is called a linear sequence because there are no squareds or anything. we can actually kind of tell this pretty immediately, and we'll see why, and we'll come back to this question when we do the lesson, if I remember. Okay, so now we're just asking straight away for the third term. You don't need to list them, just what's the third term? So see if you can remember how to do that. Awesome, well done. So you substitute in n equals 3 because it's the third term. So the nth means the third. So you pop in 3. So 3 times 3 plus 1 gives you 10. Okay, now these are the trickier questions and what we'll be focusing on mostly today, calculating nth terms. So that sequence, which of these represents what the nth term is there? With these, to be fair, you probably have enough time to work backwards from the answers, but try not to. Try to, I don't know, it gives me a better feeling if you actually work it out from the question. And this is the first thing, well, the first thing that we'll do is explain what nth term means and look at some of those beginning questions. Okay, wicked, people got that one. As I said, possibly from working backwards, possibly from just analysing the first term and stuff, but that's really, really good. Well done. Okay, next one. Same thing, a linear sequence. Let's see if you, in the same way, can work out the nth term for this one. Okay, almost there. Okay, cool. Again, majority of people getting that, which is fantastic. And well done to these people, because the main thing to spot here is actually the 6n, and we'll see why later, but well done. Okay, I think these last two are harder ones. So you'll see why once the answers come up. So give it a go. See what you think it could be. There's maybe a bit too much time on this one, I'm not sure. I don't know if people are still working on it or if that's everyone who's gonna answer. I'll let the timer go down to 20 seconds because it might, if everyone answers, it automatically skips. So, awesome. Yeah, well done. I think the options there possibly made that one a bit easier. This was a squared sequence. And yeah, as will the next one be, I think, but I think the next one, all the options for the answers are squared. So if you do know the method for working it out from the sequence rather than working backwards from the answers, give that a go. If not, I guess you can work backwards from the answers. So it is up to you. I'd obviously prefer, I don't care. It's just a quiz, isn't it? Go for what you want. Okay, I'll just let it skip again like it was last time, because then everyone's had a chance to answer. Don't worry if you're looking at this and have absolutely no idea. I'm kind of expecting that for most people. I think squared nth terms was one of the things that took me the longest to get. I hated it in school, but I like it now because I have a nice method for doing it. So hopefully by the end of the hour, you guys will all know how to do it and not hate it as well. Cool. Really well done, guys. Again, that may well have been from working backwards from the answers, but that's fine. Super impressive. So let's have a look at the podium. I think there were some high scores there. Yeah, third place. Noob and Miss Prime. Not that much of a noob. Got 6 out of 7. Maths Genie, second. Top 3 all got 6 out of 7. That's fantastic. Zitch. But well done to everybody. So let's have a look at the percentage. Oh, it did. Every time I click on feedback, does it just have it there? Do I look like a fool? Okay, 57%. So well done. Fantastic. That's going to be a very hard one to improve by the end, but I guess let's just see. Oh, I've forgotten to get up my tutor space. So we're going to start off by talking about what a sequence is, what on earth the nth term means, etc., etc. And then we're going to look at finding the nth term and consequently the higher terms of linear sequences and then squared sequences. So hopefully that sounds all right. Okay, so first things first, sequences, nth terms, and what on earth they are. So you'll often see something like, you know, the sequence 3n plus 1. Now, all this means is when we say the nth term, terms always start at 1, and it's literally just the first term, the second term, the third term, and so on. So, for example, this sequence goes 4, 7, 10, 13, 16. Maths. And that's just because I'm substituting in 1 to get my first term, I'm substituting in 2 to get my second term, I'm substituting in 3 to get my third term, and so on and so forth. Now, the key thing to notice here is that we have what is known as a common difference, and this is often expressed as D for common difference or something like that. And we can see that the difference between all of them is 3. Now, when the difference is the same, this is a linear sequence, and that's where this 3 comes from. So that's why I started doing them so quickly, because once I had got the first term, you just count up in 3s, because I know it's a 3n sequence. All this number on the end does is it changes the first term. So for example, if I had the sequence 3n plus 2, my first term would be 5, and then I just count up in 3s again, because of this 3n. Hopefully that makes sense. Do let me know if it doesn't. And yeah, if the difference between them is all the same, it is linear. So these are our nicest, our kind of most generic form of nth term equations that we want to find. And they're quite nice. So we'll see exactly how to do one, like the reverse of this, so finding the nth term now. So we'll start off on the Maths Made Easy sheet, because, you know, I know you guys will go into a crazed panic if I don't. So, for example, let's have a look at this one. This is a really, really classic question. Find the nth term and hence find something like the 100th term. Because you wouldn't want to find the 100th term just by writing out this sequence, because that's going to be a waste of your time and not fun for anybody. Whereas if we find an nth term, we can just substitute something in for n and get any term that we want to get. We could get the millionth term if we wanted to. You know, we could get terms that we couldn't possibly write out. Okay, so the first thing that I always do, write the sequence nice and big, and we think about the difference between each of the numbers. So here, as a lot of you have already spotted, the difference between them all, we are adding 7. So that means this is a linear term, and it's going to start with 7n. Now the next step seems hard, but it's actually super easy. You only need to look at one of the terms to work out what you should plus or minus on the end of this 7n. Basically, look at the first term. Imagine you're substituting in 1. So if the sequence was just 7n, term 1 would be 7. But it's not, it's 1. It's 6 less. And that's it. That's how easy it is to find that bit on the end. Literally just look at one term. And then you can check it to like, prove it for yourself for others. So for example, term 2, 7 lots of 2 is 14, minus 6 is 8. 7 lots of 3 is 21, minus 6 is 15. All this means is that this whole sequence is like 6 lower than 7, 14, 21, 28, multiples of 7. Let me know if that doesn't make any sense. Quite a few people have already got the answer as well for the 100th term. So all you do, like I said, it's nth term. So on 100th, n is 100. That's all this means. So if we substitute in 100, this becomes 7 times 100 minus 6, which is 694. Simple. And that's a 3-mark question. And I don't think that's too bad. You can see exactly where the marks come from. You get a mark for 7n, you get a mark for minus 6, you get a mark for 694. Not too bad at all, hopefully. Like I said, no one said that it doesn't make sense yet. So I'll just do one more example and get you guys to have a go. But yeah, do let me know. I'd love to move on to squared terms pretty quickly because I think they're a lot harder and they also involve linear terms. So you get some good practice of that as well. So give this one a go. Oh, no, don't. That's a squared. Give this one a go. Okay, so pop what you think the nth term and the 10th term are in the chat or the Q&A. And I'll give you guys a couple of minutes and then go through how we get there. Okay, got through a couple of answers. I'll start to go through it. Feel free to shout your answer whilst I'm doing it. Yeah, well, awesome. So exactly the same process as before. Let's write out the sequence nice and big so that we can see what we're doing. Difference between all of them. We're adding 3. Don't be thrown off just because it starts with a minus 3. You just add 3 to get to your 0. Add 3, add 3. And then we see what 3, so we know that it starts 3n, then we see what 3n would have been. Well, it would have been 3, but what are we actually on? Minus 3. So what have we done? We've subtracted 6. So there's your nth term. To find the 10th term, we substitute in 10 because it's the 10th term. So our 10th term is 24. And a lot of people got that, which is really fab. Okay. Hopefully that makes sense. Does anybody want me to go over another one of these? Or are people happy for me to move on to squared sequences? Let me know. Okay, at least one person wants to do, in fact, the only person who's replied wants me to do another of these, so I'll definitely do this. Cool. I'll do one more, then hop on to the squared ones. We've got a lot of time to come back to these if we need to. Maybe today I'll finish on time again. Who knows? Okay, so let's do another of these. Let's go to a different worksheet. Corbett Maths, also fantastic. I need to start referencing some other maths websites because which one do I want? I think this one. What's the nth term for this sequence? and I'll come up with a question, hence find the 50th term. So give that a go. This will be the last linear one, and then we'll do some squared ones. But as I say, when you do a squared sequence, you do actually have to do a linear sequence as part of that. So we will still be getting more practice on this. Fab. A few people have got it already, which is brilliant. Okay, I'll go through this one. So we've already got this written out nice and big. So the difference between each of them is 6. And then we want to know what we add onto the end, because this 6 tells us that it's going to be a 6n. Now, if the first term was a 6n, what would the first term be? It would be 6. But what is it? It's 5. It's 1 less. So there's your nth term. 50th term, we just substitute n equals 50, which is going to give us 299. So it's 300 minus 1, which a lot of people got, which is really, really good. So hopefully that makes sense. Someone said, is this lesson okay for a year 8? Isn't kind of like, what level are we at? Yeah, I'd say so, especially this stuff. The squareds maybe a bit higher, maybe year 10 or something. But if you can understand this, I'm sure you can understand the squares. So yeah, just it's always good to get ahead and get some early practice in. Okay, so let's get started on the squared terms. So let's do this sequence here. In fact, yeah, we'll do this one. We'll do this one. No. I know what that's going to come out as, and I want to do one more like this, I think, to start with. I'd rather, yeah, you'll see why. So this is the one that we want to do. So I'm going to write it out a bit bigger. 14, 33, 58, 89, 1, 2, 6. So we're going to start in the same way and look at the difference between everything. And I'll give myself big numbers, so please do correct me if I get any of this mental maths wrong. So this we add 19. Here we add 25. Here we add 31. And here we add 37. So we can tell that this isn't going to be linear because those numbers aren't the same. You know, before they were all 6, so we could write 6n. Here they're all different, so there's nothing that we can write. So what we do is we look at the next level down. What's the difference between the differences? So 19 to 25 is 6, 25 to 31 is 6, 31 to 37 is 6. So when there's a common difference at the second level, so when those numbers are the same, one level down, we know that it's an n squared term. Similarly, and you wouldn't be asked to find an n cubed term, but just know that it would be on the third level down. So if these numbers weren't the same, say these differences were 4, 5, 6, then we'd know that it would be an n cubed term because then the differences are equal. That's just interesting to know and quite useful to know. So, but you'll only ever have to work out terms down to this level. So someone has suggested, which makes a lot of sense, 6n squared. But actually, it's not. It's frustrating with this because that's exactly what you'd think. Because if 6 is at that level, it's 6n. What you do when it's a squared level is you actually half it. So what we now know is that this term starts with a 3n squared. So yeah, it's a bit of a weird one, but because it's the second level down, you half it, you divide it by 2. You'll get used to doing this as we do more and more of these. Okay, and now what we're going to do is we're going to find the sequence 3n squared, and then we're going to subtract it, because if we know that part of this sequence is 3n squared. So if we subtract the 3n squared sequence, hopefully we'll be left with the linear sequence, so whatever's left on the end. So the way that I always format these is that I write out a little table for myself to do the subtraction. So I write out the sequence, and I write out what 3n squared is. And to help me with that, I will write down what n squared is, because then I can just times it by 3 to find this. So we have 5 terms, so we'll make sure that there are 5 columns available here. And our n squareds are just the first 5 square numbers. So our sequence 3n squared is just going to be this column times 3. So 3, 12, 27, 48, 75. Now we can get rid of this n squared column. Row. I only wrote that to help me find what my 3n squared was. And then we just fill in the sequence, what we've been given: 14, 33, 58, 89, 126. So hopefully you can see that this is just a 3n squared sequence, and we're going to take our 3n squared sequence off of our original one and see what we're left with. Don't worry if you're not fully following. I definitely didn't on the first couple of times I saw this, but you will the more we do. Just try to stick with it and kind of, think about it in your own way if you need to. So let's subtract it. Let's take off. So we literally just do it by term. So 14 minus 3 gives us 11. 33 minus 12 gives us 21. 58 minus 27 gives us 31. And so on. Now what we've got is a new sequence. So this is what's left of our sequence once we take off the 3n squared. So what we do is kind of forget that it's a squared question for a minute. Imagine that this was your sequence that you had been given. What's the nth term of this sequence? This 11, 21, 31, etc. What's the nth term of that? Yeah, a couple of people getting it. So just like we did before, so find the common difference. Cool. So we do this one as we have been doing. What's the difference between each of these? 10. And it's 10 for all of them. Fantastic, we know it's a 10n. Now, if it was just 10n, the first term would be 10. But it's not, it's 11, it's 1 higher than that. So all we've done is just solve this linear, just like we were doing before. Now, all you do, because 10n plus 1 is what we had left when we got rid of the 3n squared, you just whack it back together. 3n squared plus our 10n plus 1. And that is the nth term for this sequence, this 14, 33, and so on. It's 3n squared plus 10n plus 1. Does that make sense? Let me know in the chat. It's okay if it doesn't, but I'd like to know kind of how many people get it, how many people don't. Oops. I've done this before. I go to click on the chat and accidentally click stop share. Okay, awesome. I think people get it. People aren't very, I mean, it's not a very busy webinar today, but people aren't as talkative today. Maybe because you've been at school. Okay, cool. Oh, wicked. People are replying now and saying that they get it, which is awesome. That's really, really good. So I'll go through one more worked example and then give you guys some to just have a go at, and I'll leave you for a couple minutes and see if you get it. Okay, awesome. Thank you for responding, guys. It does help me a lot to know if I'm explaining things right because otherwise, I need to change how I'm saying things. So let's have a go at this one. So remember, we start by seeing what the difference is between each of these terms. Okay, someone said, perhaps we could write down the steps in the process. Sure. So I'll go through this one and then write like a numbered list of what you can do. So you have like a little cheat sheet of what we do at each step. Someone said I'm going too slow, which is, I think, a good thing at this stage. I'm quite happy. I'll speed up a bit after this one. But I like to make, the harder, I think this is a harder topic. Maybe it's just me. I think this is a harder topic, so I like to go a bit slower. So I'm glad that's coming across, actually. So we find the difference, 14, 17, no, 18. Oh my gosh, embarrassing. 22, 26. Okay, and then that's still not equal, so we do another level. 4, 4, 4. Now those are. So what do people think the n squared part of this is? Okay, cool. Yeah, a couple of people got it. 2n squared, because it's half of what it is, unlike with n. So I always just write this at the top to come back to 2n squared. Now we're going to set up our little table. So what I always write is n sequence 2n squared. Oh, sorry, n squared sequence 2n squared. And again, we have 5 terms, so let's make sure we have 5 columns available. And our n squared is always the same. And remember, this is just to help us then easily translate this to the 2n squared, just by multiplying all of these by 2. Then I always cross out this row, or mentally crossed out at least, because I know that we don't need it anymore. Otherwise, it can be confusing as to the calculation that you're doing. Then we just copy out the sequence that we have. And then subtract these, because if we take out the 2n squared, what we're left with will be the linear term. So 3 minus 2 is 1, 17 minus 8 is 9, 35 minus 18 is 17, 57 minus 32 is 25, and 83 minus 50 is 33. And now we've got this new sequence here. We solve this as though it were a linear sequence, which it is. Difference of 8 between everything here. So we know it's going to be 8n. And then we think if the first term was 8n, it would be 8, but it's not, it's 1, it's 7 less. So our final term, we combine these parts to 2n squared plus 8n minus 7. Awesome. Lots of people got this really quickly, which is fantastic. So let's write out what steps we did there. So number 1. So, okay, solving n squared terms. So this just works for n squared, because for a linear sequence, you stop at the first level. So it's list difference at the first layer, list difference at the second layer, and we'll call this difference at the second layer d. Then we know that it's half of whatever d is squared. So in the previous one, d was 4, so it was 2 squared. You half whatever that thing is in the second layer. Then we do the sequence minus whatever our squared term is. Then we find the nth term of the resulting sequence here, this one that we just found, and then combine them. So we combine steps 3 and 5. The half d squared and then the nth term of the resulting sequence. So maybe screenshot this or take a photo or something if you think you need it, if you think it will be helpful little cheat sheet of what it is that you do. I think looking at that makes it look more confusing, but once you've seen it, it's actually very, alongside the example, it makes a lot more sense. Yeah, but I know that I always used to find things like this helpful, just a short little summary, so hopefully it will help you. So let's have a go. You guys have a go at one. So I'll give you a couple of minutes, give this one a go, see what you get. Even if you can only get part of the way, just put what you have or what you think in the chat. If you give an answer, I'll reply to you telling you if you're close or right. Okay. Let's start going through this. Again, feel free to pop your answers in the chat as I'm going through it if something suddenly clicks or you just finish it. So let's go through the first level of differences on here. So 10, 12, 14, 16. Not the same, so we go to another level of differences. Now the difference between all of these is 2. So we halve that, so we know that our first part is an n squared. So now we don't even need to write our n squared as a separate thing to help us. We can just write sequence and subtract n squared from it to see what we're left with. So as per, we've got 5 terms. Let's write our n squared, fill in the sequence, and do our subtraction. 13 minus 1 is 12, 23 minus 4 is 19, 35 minus 9 is 26, 49 minus 16 is 33, and 65 minus 25 is 40. Yeah, those are correct. And now we've got a linear sequence. So we find the nth term of this. Well, the common difference here is 7. So we know it's a 7n. If the term was just 7n, the first term would be 7, but it's not, it's 12. It's 5 more. Then we just do our nice and easy final step, whack these bits together, n squared plus 7n plus 5. Boom. And a lot of people got that, which is really, really good. And some people got it there as I was going through it. So really good job. Well done. Let's go through one more of those, because there's one more on here. So what I think we'll do is go through this one again. Feel free to start it now. I'll give you guys a couple of minutes, then I'll go through it. Then we'll do the final Kahoot, and I'll go through each of the questions. Like, I'll actually let you guys do them on the Kahoot, then go through them here in this whiteboard space. And then if we have time, we'll maybe look at some word questions, but I'm not sure if we will. That's not something I needed to get onto today anyway. I don't actually know how many word questions there are for sequences. This is normally what they're like. Find the nth term of this, and hence find the 100th term or something like that. So yeah, I'll shut up and let you guys give this one a go. This one may be a bit trickier, not sure. Let's see. Okay, I think I'll go through this one because it seems to be a bit harder, but feel free to pop your answers on whilst I'm going through it. Okay, so first thing that we're going to do is write down our common difference. So 14, 22, 30, 38. Not common, so we write the next one. 8, 8, 8. Perfect, they're the same. So we half that and we know it's a 4n squared. So we write what we always write, n squared, the sequence, and our 4n squared this time. Remember, our n squared is just there to help us write our 4n squared. Because n squared, we get used to writing, we can write this very easily. Now multiply all of that by 4. 8 and 100. That is not 16 times 4, that's 16 times 3. 64. And then we get rid of that first row or ignore it. Fill in the sequence that we have. So 6, 20, 42, 72, 110. Let's do our subtraction. 6 minus 4 is 2. 20 minus 16 is 4. 42 minus 36 is 6. 8, 10. Perfect. Now we've got our new linear sequence. Let's look at the common difference here. It's 2. So we know that it's got to be a 2n. Now, if the sequence was just 2n, what would the first term be? It would be 2. And it is. So we don't need to add or subtract anything from this. So we just combine our final parts. And there you go. 4n squared plus 2n. This one, I think it can be a bit more confusing because once you're used to doing ones like this, it seems a bit strange. But it doesn't have to be. The other thing that we could get is if this, and I'll try to show one at the end, if we have a term like this, where all of these subtract and give us a constant, then that's just what we add. So in fact, I think I've got time to do one, and I think one of these gives it. Let's hope so. So with this one, for example, there's many terms here. The difference is 6, 10, 14. Then the difference here is 4. So we know that it's got to be a 2n squared. I'm doing this quite quickly because it's just this last bit that I want to show you, and I think you guys have got the grip of this bit now. So we write n squared sequence 2n squared. This time we actually only have 4 terms, which isn't loads, but it's just enough to be able to work it out. So we write 2n squared for all of these, get rid of that first row, write in our sequence, and then do our subtraction. Now, see, our subtraction gives us 4 minus 2 is 2, 10 minus 8 is 2, 20 minus 18 is 2, 34 minus 32 is 2. When they're all the same, if you think about it, the common difference is 0, so it's 0n plus 2. So this is just 2n squared plus 2. Because the nth term for this sequence is just 2. Because what it doesn't matter what the value of n is. The millionth term is 2. The 10th term is 2. Right. Someone just asked a question, but I'll answer that whilst we're logging into this Kahoot. I'm hoping it's the same level of difficulty as the one at the beginning, but I guess we'll find out. It's normally not. I normally accidentally make it too hard, but we'll see. So again, Kahoot.it or get the app. Someone has asked, can you have a sequence with a difference n cubed? Yeah, absolutely. You wouldn't be asked to find the nth term, but if you were, basically you'd get the n cubed at the third thing, and I think you divide it by 4 then, because I think you divide by like 1 for the first, 2 for the second, 4, so like 1, 2, 4, 8, so on, and you get your n cubed. Then you would take off the n cubed and be left with the squared, and then solve it in that way. So you can just keep going. But that's too much for GCSE or even A level. Like, I've never seen a question where they actually ask you that. But it's important to know that if the common difference is at the third level, it's an n cubed nth term. Hopefully that makes sense. Okay. Okay, I think most people are in. Just give it 30 seconds or so, and then we'll get going. Oh, we've lost a player. Shame. Okay, I'll just get started. It doesn't look like anyone else is joining at the moment, but it's open so you can join throughout. 9 questions on this one. So let's see. Nice and easy to start you off, hopefully. Right, the first 5 terms for this sequence here. Awesome, well done. If you put this one, which a few people did, you got the first term right, but then because it's an n, that means that it's increasing by 1, and when negative numbers increase, it looks like this one. So question 2, another nice simple one, just write the first 5 terms for that sequence. So once you've got the first term, now we know what it means for it to be 2n. You can just actually work out the rest without having to substitute n in. It's up to you, whichever way works best for you. Awesome. If you put this yellow one, again, the first term was correct, but remember it's a 2n, so it has a difference of 2 each time. Okay, this one, you don't really even have to work out the nth term, just work out the difference, see what you think the next 2 terms are. Awesome, really, really good job. And to the person who put +3, you're right that that's exactly what the rule is, just not quite what the question was asking, but fantastic stuff. Well done. Okay, so now if a sequence has that nth term, what's the 5th term? Think about what you need to substitute. So n squared minus 3n plus 1. Brilliant, really, really well done. So you just substitute 5 into that. Let's see what you get. Okay, our first nth term question. So what's the nth term of that sequence there? Awesome, well done. So the reason is because we see that the common difference is 4, so it's got to be a 4n. And then if the first term was 4n, it would be 4, but it's not, it's 5, so it's 1 more, so we add 1. Similar question, what's the nth term for this one? Don't worry if you're not sure. I think most people have answered, but I'll just let the timer go down anyway. We're in nice time. Okay, let's see. Oh, brilliant. Well done. And the other 3 who went different, you did exactly like kind of what that's there to trick you into doing. But I'm super, super impressed that everyone got that it was minus 2n. Fantastic. Because I guess we haven't done decreasing before. So well done for spotting that. The reason that it's plus 14 is because it's a minus 2n. So if this was the sequence, the first term would be minus 2, but it's not, it's 12, which is actually 14 more than minus 2. But I can totally see where the mistake came from in the yellow answers, so don't worry. Okay, what's the nth term for this sequence? Okay, I'll skip it when it gets down to 20 because we only got 13 answers last time. Yes, look at that. We got 100% question. I don't even know if we've ever got that before. Yes, well done. Okay, last 2, and these are going to be squared terms. So give these a go. See if you can remember how to do it. Whilst you're doing that, someone's asked, what are the benefits of doing further maths? Which is a really good question. I guess you mean at GCSE. So, okay, two main things that I can think of. First of all, if you're going to do maths at A level, further maths at GCSE really, really prepares you for that. It's a really nice bridge between them because you start to cover some stuff in further maths GCSE that you then cover in A level maths. The other thing is, there's much more interesting maths because you don't just cover the basics on the curriculum, you cover some more interesting stuff. I think it can make maths a lot more enjoyable, or at least I enjoyed further maths a lot more because you start to introduce some different concepts, I guess, and like some more interesting maths, in my opinion. So there you go. And it's an extra qualification. Yeah, so if you're enjoying maths, I'd really recommend it, but yeah, there you go. That's just my opinion though. I'm going to let this timer go down just because not everyone's answered yet, probably because I'm distracting you by talking at you. So ooh, okay, interesting. A difficult one. Although at least people who went for this one, you got that it was a 2n squared. So that's really, really good. Let's have a quick look at, oh, that is not what I meant to press. Oh gosh, nobody wants to see that. Right, okay. Boop. I'll go through this super, super quickly. So, differences on the first level, 8, 13, 17, 21. Differences on the second level, 5, oh gosh, I've done something wrong. That's 9, 4, 4, 4. So it's a 2n squared because that's 4. Let's do our table. N squared, sequence, 2n squared. We've got n squared being 1, 4, 9, 16, 25, which gives us 2n squareds here. Our sequence, do the subtraction, and we get -1, 2, 5, 8, 11. Differences here of the +3 each time, so it's 3n. If 3n was the first term, it would be 3, but it's not, it's -1, so it's 3n minus 4. 2n squared plus 3n minus 4. Oh, apparently it's 2n squared plus 3n plus 2. Did I do something wrong? Anyway, that's where the 3n comes from. Interesting. I'm not sure what I did there, but I'll look over that whilst we do the next question so that we finish on time. Final question. Oh, was the answer there wrong? Is that why people were thrown off? Because I pull, oh, okay. Because I pull these from other Kahoots because there are already Kahoots out there. So I'd rather, get other resources. My apologies. These are like, verified popular Kahoots, so I assumed it would be correct. My fault. I'll check them next time. Tricky one here. We haven't done a decreasing negative one before, but let's see. Okay. I won't bother skipping because we only have 10 seconds. Awesome, well done. Okay, this one I've just checked. This one is actually correct. I don't have time to properly go through it, but you see we have -3, -5, -7, -9. So the differences there are -2 each time. So we've got a -n squared, if you subtract minus n squared, it's like adding it. And then you'll see that the sequence just comes out as 4, 4, 4, 4, 4, 4, which we discussed is a sequence of 4. So it's minus n squared plus 4. So let's see the podium. 8 out of 9, I'm going to count as 9 out of 9 because of that horrible question that was wrong. So well done to Henry, the 7th /SSB, Paul, and square root of -1 equals I. See, that's the kind of stuff you learn in further maths, I think. Okay, fantastic. Really, really impressed with that. Yes, and we even improved the percentage, even with a question that was incorrect. So fantastic. I haven't got a maths joke for today. I'm really sorry. I'm trying to think if I know any off the top of my head. What? Why? Okay, so this is a trig one. It's not actually a anything to do with sequences, but it's the only one I can think of. Why did I divide sine by tan? Just cause. And that's because sine divided by tan is cos. Awful. That's what happens when I don't prepare a maths joke. They're awful even when I do, but anyway, thank you all for coming. This is recorded and put on the MyTutor YouTube channel, so check that out if you want to listen to that fantastic joke again. Make sure to check out the MyTutor website if you're looking for any one-on-one tutoring or anything. We offer that. And check out the upcoming schools timetable. We are still doing 1 lesson a week, 1 in each of the core subjects. So I will see you guys again next Friday, a whole week. Heartbroken, honestly. You'll have to come up with your own jokes every day because it's too sad. But thank you all for coming. I hope this has been useful, and I'll see you next week. Bye.